feel like my Space Invaders would feel so much safer if I had shields to stand behind. And that's what we're going to do now. So in the previous videos, we've implemented everything you see on screen so far. We have reset functionality that we still need to implement, and then we need to implement our shields, and then a victory screen, and we're done. So if you're just now tuning in, you just now somehow stumbled upon this video, make sure you check out the entire playlist so you can learn to build this from scratch, from start to finish on your own with Zig and Raylib, and have a really fun time doing it and hopefully learn a lot in the process. You can do that on YouTube via the playlist. You can do that on courses.bradseipert.com completely for free, and that includes supplemental text information and an optional quiz at the end to hopefully help cement some of the core concepts that we've really driven in while learning this, how to build this. Let's get to it. Let's put those shields up. So in classic Space Invaders, you hide behind destructible shields. So we kind of need those if we're going to call it a Space Invaders clone. So let's add those now. So we can go all the way up to the root scope above our main method. We're going to add another struct. So this is going to be, not const. This is going to, or not pub. This is going to be const shield, and it's going to be a struct. We have some pretty common values. So we have our position X, we have our position Y. We have our width, which is going to be a float 32. We have our height, which is going to be a float 32. And we have our health, which is going to be an I32. What is health? Well, so in Space Invaders, conventionally they have health. They degrade over multiple hits. They don't have an active or alive status. So the shields can take multiple hits before they disappear. So that's what we're going to do. So we're going to create an init function, just like we have for every other struct. So we have our position X, position Y, our width, and our height. And it's going to return this. So we have our position X, which is going to be position X, position Y, which is going to be position Y. And sorry, I'm glossing over these a little bit, but there's not really anything interesting going on. If you've made it this far, you should have a pretty good understanding as to what this init function does, what anonymous structs are, what this is, how we're matching the fields to make sure that we're returning the right thing, all of that jazz. We're going to set the default health to 10, though. Give it 10 hit points so it degrades over time, and that should work out nicely. We know that we need to support collision, so we're going to go ahead and implement that getRect function. And by implement, I mean we are just going to steal this from another function that another struct that we've implemented it on. So I can just paste that right here. Looks good. These fields match, so everything is good to go there. Now we need to position them across the screen. So we want to position multiple shields. We're going to create 4 shields spread across the bottom of the screen. So in our main method, we're going to do this entirely based off of variables. So if we wanted to change this, all we have to do is change the values here. So we have 4 shields, shield width equals 80, const shield height is equal to 60. I have a typo. I've got several typos. Let me fix those really quick. Sorry about that. So SHIELD width. Okay. So I've been typing for like 3 hours straight. So pardon the typos. Okay. Shield height. We have our shield start X, which is going to be like 150. This needs to be a float. Don't let that mislead you. And shield Y is going to be 450. And then finally, we have some shield spacing. So shield spacing is equal to 150. Okay, we've created some constants. Now we actually need to use those, right? You can't just create them and not use them. So somewhere around here, we'll actually do the shields before our bullets. So we can create shields. And again, this is going to be an array, very similar to the way that we do bullets and enemy bullets. So it'll be a shield. We'll set it to undefined by default. We'll iterate through those. So we have shields and we're going to have a range starting from 0. We're going to capture those in this capture group, or this payload capture. So we have our shield, and what we want to do is come up with our X position via our shield start X plus, and then we use our as built in to coerce this to a F32. And we also use our float from int built in to get a float from an integer value. And then we multiply that by shield spacing. Now we actually need to initialize that. So we're going to dereference the shield here and say shield dot init x shield y. And then for our width, we'll do our shield width and then our shield height. Great, so we have 4 shields that are going to be positioned across the screen, 150 pixels apart. And they set at a y-axis value of, I think we set it to 450. Yeah, see it at the top of the screen, it is 450. So it's going to be between the players and the invaders. Now let's draw them with a visual that shows their health. So the shields are going to block the bullets from the player and enemies. In your bullet invader collision loop, after checking the invaders, we're going to add some code to handle this. So we'll come to, I've got this on line 370. Yours may vary, but essentially when we want to hop into this loop that is checking the bullets and if they're active and then handling collision with invaders. And this is actually going to be really similar, but what we're going to do is if the bullet's active, so in the same scope, we're going to do a for, and then we're going to take the shields and we're going to capture a shield. And sorry, I want a pointer here. And then we check if shield health is greater than 0, and then if bullet.getRect intersects with shield.getRect, then the bullet becomes inactive, and the shield health decreases by 1. And then we can break, because we want to make sure that we are not continuing with that same bullet check. Okay. So if the bullet's hitting a shield with health, deactivate the bullet and decrease its health by 1. Similarly, we need to do the same thing with our enemy bullet collision, because shields are essentially a neutral party. They are damaged by every type of bullet. So they're not hostiles and they're not allies. They're in between, and unfortunately that means that everything hurts them. So what we want to do is find our enemy bullet collision code, which is right here. And then after checking the player, which is right here, we're actually going to do basically the exact same thing. So I'm actually going to come up here. I'm going to go into visual. I'm going to yank all of this. We'll come down here. We'll paste it. I'll let Zig auto format that for me. And then the key thing here is that we need to, actually, I think we're good. So we have our shields. I don't think we need to change anything. We check the health value. We use the bullet. We get the rect. We check the intersection with the shield. And if it's we set the bullet active to false. We decrement the shield health, and then we break. So yeah, I think we're good. It's the same logic. And the shield is protecting from both directions. So what we want to do is visualize that shield degradation. And I think in the actual Space Invaders game, it's like pixelates and it chips off parts of the shield. I'm just going to do this with alpha transparency. We have modern computers, and they're really good at rendering things with alpha transparency. So I think that seems like a fun way to approach it. And honestly, it is a little easier probably than trying to swap out the image or the structure of the drawing every time it gets hit. Okay, so what we want to do is go up to our shields, which is somewhere up here. Yep, all the way up here. And we need to draw them, right? So let's create a pub fun draw self at this, and it's going to return void. It doesn't need to return anything at all. So if self.health is greater than 0, we're going to do this stuff. If it's less than 0, we don't need to draw anything. They need to not exist, in fact. So we won't worry about drawing them. And it's worth mentioning, with the code we're doing here, we're only drawing them if the health is greater than 0. So how do they not get drawn? That's a really great question. If you remember very, very early, one of the very first things we added to our game loop was a clear functionality where we just draw a black background to clear everything. So essentially on every frame, we are redrawing everything over the clear black background. So that's how that is being undrawn, if you would call it that. Okay, so we need to get an alpha value. This is actually going to be a U8, so we're going to use the as built-in to get a U8. We're going to use another built-in you haven't seen yet, at least in this series, to do an int cast. So we want to cast this to an int. We're going to use another built-in. They're all over the place. You got to learn these things. It's tricky. I wish there was a better way to make them more prevalent in your learning journey with Zig outside of just like having them shoved in front of you, but it is what it is. So we want to take the minimum value between self.health times 25 and 255. So essentially give us some alpha value. I also need an equals here. Not sure why I forgot that, but I did. And then what we want to do is the same thing we've been doing all over the place. So much, in fact, that I am going to steal it once more. We'll come up here and we will yank the draw rectangle functionality. Come back here, we'll paste it. I did miss a semicolon. The catch, however, is that our color is going to change. We're going to use that alpha value. So what we're going to do is use rl.color, and instead of using a value on this, I guess we could use the init method here. That might not be bad. But one thing you can also do is just inline the struct. So I could say r is equal to 0. I want G equal to 255, and I want B equal to 255, and I want A is equal to alpha. That would actually be pretty similar to the init method, and arguably maybe the init method is the right approach because it does something else. But I just want to show you that you can also inline structs like this. It is totally fun. Okay, so that gives us our alpha transparency based on the health. So with 10 health, the alpha is 250, which is going to be nearly opaque. And with 1 health, it'll be 25, which is mostly transparent. The minimum is going to ensure that we never exceed 255, which is a constraint we need for alpha channels. And then the color is going to be cyan. It's going to be 255 green, 255 blue, and 0 red. So in our game loop, we need to draw shields before other objects so the bullets render on top. We hadn't really talked about this yet, but the order in which you draw things does matter. And I kind of hinted towards this in a previous video, but I mentioned essentially drawing in layers. And when we were talking about clearing, how we clear things in layers. Clear things by adding essentially a new layer on top of it. So the order in which we draw does matter. Keep in mind that we're essentially taking a pixel value, we're going to that pixel value, and we are changing the pixels to be what we would expect them to be. So if you were to draw something first over pixel 0, 0, and then draw something else over pixel 0, 0, well, the second thing you drew is going to take that spot. So it does actually matter. So in our draw logic, we're going to come down here, and the very first thing we're going to draw are our shields. So for shields, we're going to capture shield, and we're going to say shield.draw. I think this should cover it, so I'm going to run zig build run. We do have an error. I've missed something somewhere. Shield init ignored. Okay, I've made this error so many times. It is the exact same thing. 244, I just need to return a value here. I was not returning it. Sorry about that. Boom, we have these chunky shields. Kind of love it. And you can see them starting to deteriorate. The aliens are blasting them, or the invaders are blasting them, and we can blast them too to get through and punch holes in those invaders, but oh no, our shield is gone, and now we've been hit. We have, like, at this point, like a pretty good game, and I really want to stress one more time, we're at 506 lines of Zig code. That's really not bad. So in our last module, I think we have one more to go. So in our next module, what we're going to do is finish out that reset functionality, we're going to take all of our constants that we've been building and build these into that game config struct and really kind of clean some stuff up, and then make sure that when you win, when you defeat all the invaders, you're also congratulated. But also when you are hit by an invader bullet, you are able to restart the game and continue playing, and hopefully enjoy it. I will see you in the next module.